Welcome to the session. Myself, I am Shravani, Assistant Professor from the Department of CSE. Today we will start our next unit, which is dynamic programming, which is another programming paradigm or algorithm technique. And in the last lecture you have seen greedy approach. Okay, in your greedy approach, what happens here? You are going to find the optimal solution by taking the feasible solutions. So here there you are finding all the number of approaches. Okay, here what are all the number of approaches to have the feasible solutions. So what are all the feasible solutions? So basing on those feasible solutions, you are going to get the optimal solution basing on the problem, that is either the maximization problem or the minimization problem. Basing on the problem, you are choosing the optimal solution from the given feasible solutions. That is your greedy approach. Now we will see another approach, which is dynamic programming, right? So before going to this particular unit, I am dividing this unit into two modules. The first module is corresponding to applications and the second module is corresponding to multi-threaded algorithms. As I said, the dynamic programming total complete unit I am dividing into two modules. The first module corresponding to applications. So after learning what is meant by dynamic programming and what is a general method, so here in this particular unit we are going to learn the applications, several applications corresponding to dynamic programming. So the applications are matrix chain multiplication, 0 by 1 knapsack problem, all pair shortest path, traveling salesman, and string editing and reliability design. Now not only the applications, we are also seeing multi-threaded algorithms. So about multi-threaded algorithms, how we are applying this dynamic programming on this multi-threaded algorithms also we are going to learn as part of this particular unit. And here in this module I am going to learn basics, multi-threaded matrix multiplication and multi-threaded merge sort. So multi-threaded multiplication followed by merge sort, multi-threaded we are going to learn as part of this particular unit. Right. So here, as you have already learned knapsack problem as part of greedy method, what is meant by knapsack? So here knapsack or a rucksack problem. So here there are certain number of items are given to you and whose weights and values are also given to you, and this is a maximization problem such that here you are going to here you are going to take all the items into the knapsack such that you should earn the maximum profit, and it should not exceed the knapsack capacity. In such a manner you are going to fill your knapsack, right? That is your knapsack you have learnt as part of greedy. And one thing, in your greedy approach, what you have done? So if at all 1/3 portion is left in the knapsack, even that 1/3 portion or a fractional part is also you are going to fill it up, right? Whenever some empty space is left in the knapsack. So even fractional part also you are going to fill it up, right, when you are going to use a greedy approach. Whereas in your dynamic programming, what you are going to do is, here if at all, if the space, complete space is available, then only you are filling the knapsack, otherwise you will not fill it, right. So here 0 by 1 corresponding to 0 stands for the item is not taken, 1 stands for the item is taken into the knapsack. That's why the name itself is 0 by 1. So either I will take the complete item or I will reject the complete item. That's why it is 0 by 1 knapsack. So previously it is greedy knapsack and now this is changed to 0 by 1 knapsack in this particular unit. Now, not only that, we are going to learn some more applications also, all pair shortest path, TSP, and reliability design, string editing. And one more thing, my dear students, please remember. So here in dynamic programming, whenever you are solving the problems using dynamic programming, it is very, very important for your competitive examinations, because at present all the campus placements you are going to write online, right? So here for writing your exam through online, here they will be given you some programs like some case studies, and those case studies you are going to solve, right? So most of the problems will be solved with the help of dynamic programming. Why you have to choose dynamic programming? Because it takes a very less time. Okay, it takes a very less time, and the companies are seeking for that only. Not only the programmers who efficiently writes the programs they required, right? So if you are using this approach, most of the problems will be solved. So please try to pay attention and try to pay concentration on this particular unit. Okay, and one more thing here, whenever a problem is given to you, the solution is in your hand. Before solving the solution, here the solution will be in your hand whenever a problem is given to you. So please try to pay attention towards this particular unit, right? Now, in today's lecture, I am going to cover what is meant by dynamic programming and what is a general method of it. Okay, so before going to applications part and all, here first of all I should know what is meant by DP, right? So that we are going to learn as part of today's lecture. So today I am going to cover general method of general method of dynamic programming, and the main principle which follows all the DP problems is principle of optimality, and also we have seen what is meant by divide and conquer, what is meant by greedy method, and why we are learning this DP again. So here you must have all the what are all the modifications we have, and also what is the difference between DP and DNC and greedy approach, right? So that also we are going to cover as part of today's lecture. And coming to the lecture objective, right? Today, as part of this today's lecture, the students are able to learn the concept of dynamic programming. What is meant by dynamic programming, what is the principle it is following, how we have to apply, right? Now, coming to the outcome. After learning this particular lecture, the students are acquiring the knowledge on the concept of dynamic programming, mainly the general method of dynamic programming. Okay. Now, what is the definition of dynamic programming? Dynamic programming is a general algorithm design technique for solving problems. As I said earlier, here all the algorithm techniques what we are learning as part of today, okay, as part of this course, you are all learning for solving the problems, mainly for solving the problems. So this technique is also used for solving the problems defined by or formulated as recurrences with overlapping subinstances. So here we are formulating the recurrences, which means that here we are writing a recurrence relation such that it has some overlapping of subproblems. So with that we are going to find out our solution. And this dynamic programming approach is invented by Richard Bellman in the year 1950 to solve the optimization problem. So what is meant by optimization? Optimization means here the solution whatever you are giving, that is the best solution. So feasible means all the possible solutions. So out of feasible solutions you need an optimal solution. So optimal means the best solution out of all the possible solutions, right? So to get the best solution from some set of solutions, here this approach is mainly used. So that's why it is used for solving the optimization problems. The basic idea behind dynamic programming is to set up a recurrence relation. So here, basing on the recurrence relation, we are going to find out the solution. So solution to the larger instances. So here, basing on this recurrence relation, we are going to find the solution for the larger instance, and this larger instances, okay, this larger instance solution I am depicting with the help of recurrence relation, and itself the recurrence relation itself, it is using some smaller instances. So here I am going to solve the smaller instances, and basing on that I am going to solve the larger instance, and the smaller instance solution I am copying it, and here with that I am going to find out the larger instance solution. Now here all the smaller instances we are going to solve only once. Please remember, in dynamic programming we are going to solve the smaller instances only once, and we are going to store all the smaller instances in a table, and that that particular saving, okay, that storing these details into a table is called as memorization. So here record all these solutions into a table, and this process is called as memorization, and after that extract the solution to the initial instance from the table. So here what is our required problem? So basing on the problem instance, I need to take the solution from the memorization table. Okay, this is the basic approach we are following in the dynamic programming. Here where we have to apply this. So this is applicable when subproblems are not independent. Here when the subproblems are not independent, what it means? The subproblems are dependent, right? So if the subproblems are dependent on one another, then this particular thing, this dynamic programming approach is used. Now a divide and conquer approach, okay, so here also I am telling smaller subproblems and larger subproblem instances, right? So maybe this is also divide and conquer, that can be your next question, right? So here the thing is divide and conquer. What happens in your divide and conquer? Here each and every smaller problem instance I am going to solve independently, and finally I am integrating all the subproblem solutions to get the overall solution, right? Whereas here if one smaller instance is depending on another smaller instance, then I will not, okay, I will not calculate, or I will not find once again the smaller instance. I will only calculate once and I will reuse it again and again to find the next subproblem or the next sub-subproblem instance. Now here the dynamic programming solves every subproblem just once. Please remember, just once, and stores the answer in a table, and from there I am going to retrieve the corresponding smaller subproblem instances to have the solution for the larger instance. Whereas here in your divide and conquer approach, here repeatedly we are going to solve the common subproblems. Common subproblems we are repeatedly solving, whereas here we are solving only once and we are reusing it. Finally, I can say, in short, the dynamic programming utilizes the recursion plus reuse. Why? It uses a recurrence relation. Recurrence is nothing but recursion, followed by reuse. Once I will solve the smaller problem instance, and I will only once I will solve it, and I will store it in the memorization table, and after that I am retrieving it, right? So only once I am finding the solution, and after that I am reusing it again and again to have the solution for the next subproblem instance. That's why it is recursion plus reuse will yield us dynamic programming. So here dynamic programming is recursion plus reuse. Why this is used? Okay, where it is exactly used? Mainly, as I said earlier, this is used for optimization problems. So here optimization, a set of choices must be made to get an optimal solution. So here there are a number of choices we have to make to get an optimal solution, and also we will find a solution with optimal value, that is either the minimum or maximum, that is basing on the problem, whether we are going, okay, whether we had a maximization problem or a minimization problem. So as I said, knapsack problem, right? Knapsack is a maximization problem. Here you are writing maximize summation pi xi. So here maximize summation pi xi. So maximum profit we need it. So here this is a maximization problem. Whereas if you are finding a route from one city to another city among 5 cities, so in that case what I required, I have to reach my destination as early as possible. So here I require a shortest distance to reach my destination, right? I require a shortest distance. So this problem is come under minimization problem. So here minimal distance I required. So this is a minimization problem, and this knapsack is a maximization, this one is a maximization problem. So basing on the problem, we need to choose a corresponding optimal solution, either the maximum one or minimum one. So if it is a maximization problem, I need to have a maximum profit. So which one is a maximum profit yielding? That corresponding solution I should take. Whereas a minimization problem. So here, which particular route is giving me the minimal distance or the shortest distance, that route I have to take. So that is come under minimization problems. That's why it is either the minimum or maximum. Now, there may be many solutions that lead to an optimal value, right? There may be many solutions, but I am choosing the best one that will be the optimal value. What is the main goal behind dynamic programming? The main goal is to find the optimal solution. So whatever we are doing, the main thing is to find the optimal solution for the given problem. What are the different steps to develop dynamic programming algorithm? So these are the 4 steps. The first step is characterize the structure of an optimal solution. The second step is recursively define the value of an optimal solution. Next one is compute the value of an optimal solution, and most probably, typically if you use a bottom-up fashion, you will get it fastly. Now, construct an optimal solution from computed information. So here the first one is characterize the structure of optimal solution. So in which structure? For example, a tuple solution. If I want to represent a tuple solution, so the tuple solution can be like this: 1, 0, 1. Okay. Otherwise, if I want another solution of like variable type, so here x1 is equal to 1, x2 is equal to 0, and x3 is equal to 1. So which type of solution? So this is one type of solution and this is one type of solution. So which type of solution you want? You have to specify. Next, recursively define the value of an optimal solution. So recursively you have to define what is the value. Now, compute the value of an optimal solution typically in a bottom-up fashion. Now, construct an optimal solution from computed information, and this is not always necessary. Basing on the problem instance only, we have to go with the 4th step. Here for dynamic programming problems, basically it has to follow one principle called principle of optimality, the principle of optimality. So what is the definition of principle of optimality? We will see now. The principle of optimality principle states that an optimal sequence of decisions has a property that whatever may be the initial state and the decision are, the remaining decisions must constitute an optimal decision sequence with regard to the state resulting from the first decision. That is, here basing on the previous decision, I should get the result for the next decision, right? So that is the basic fundamental in the fundamental used in the principle of optimality. So here an optimal sequence of decision has a property that whatever may be the initial state and decisions are what type of decision you have taken, either in this path or this path or this path or whatever you have chosen for the next level, and the remaining decisions must constitute an optimal decision sequence with regard to the state resulting from the first decision. That is, here from the first decision you should correspond to the next level. Now, essentially this principle states that optimal solution for a larger subproblem contains an optimal solution for a smaller subproblem. Basically, the larger subproblem solution constitutes the smaller subproblem solution. That is a basic idea behind the principle of optimality, and we have to follow this principle of optimality throughout the problem whenever you are finding a solution by using dynamic programming approach. Dynamic programming versus greedy approach. As you have already seen greedy approach, I am just giving you the basic difference between dynamic and greedy approach. Here in greedy method, only one decision sequence is ever generated. Only one decision sequence. Whereas in the dynamic programming, many decision sequences may be generated. Many decision sequences. Many number of decisions, either in this path or that path or this path. Likewise, we'll be having number of decisions. Okay, number of decision sequences we will be having in the dynamic programming. Whereas in the greedy approach, we will be having only one decision sequence, only one decision sequence in the greedy approach. Coming to the next one, dynamic programming and divide and conquer. What is the basic difference? So here, as we have already seen, that in your divide and conquer, we are going to find, okay, we are going to find each and every sub problem. Okay, we are going to solve each and every sub problem independently. Whereas here each and every independent sub problems we have to solve recursively, and then we need to combine all these sub problems to get the solution in your divide and conquer. Whereas in dynamic programming, here the sub problems are not independent. That is, here the sub problems will share the sub problem. Here each sub problem will share the sub problem. So here solves every sub problem just once, and we are going to utilize this solution whenever you are solving the sub problem. Now here I am showing you the example to have the difference between DP and DNC. So let us consider the Fibonacci sequence. So in your Fibonacci sequence, this is a basic logic behind the Fibonacci sequence. Okay, so here fib of n, here fib stands for algorithm name, and n is a nth generation Fibonacci sequence I required. So n is a n is a number. So if n is less than or equal to, simply return 1. Otherwise, I am returning fib of n minus 1 plus fib of n minus 2. So here for this, what I required basically, for suppose if I want to find fib of 4, so this fib of 4 can be found by taking the sum of fib of 3 and fib of 2, and this fib of 3 can be found by taking fib of 2 and fib of 1, and this fib of 2 can be found by using fib of 1 and fib of 0, right? And this fib of 2 again, it can be found by using fib of 1 and fib of 0 by taking the sum of these two. So now here fib of 1 solution already we have, that is 1, and 0 means it is 0. Here as it starts with 0, 1, 1. Now here fib of 1, this is also 1, and this is also directly I can have the solution, which is 0. And here fib of 2, 0, 1, 1, right? Even this is also 1. Here fib of 1, fib of 2 is equal to 1, right? So now fib of 3. So to find fib of 3, I have to find this fib of 2 once again, and even this fib of 1 once again, and after that I have to add these two. To get the fib of 3. Now to have fib of 4, here I have to compute this fib of 3 and then fib of 2, and then I need to perform the sum to compute fib of 4. So each time, whatever may be the problem, the sub problem, for each and every sub problem, I have to compute it, and I have to perform the sum, and I have to get the value, right? Whereas here, if you have seen clearly, this fib of 3 requires fib of 2, right? So here also in the right subtree I am finding fib of 2 alone. So if I am, okay, here also I am finding fib of 2 separately, here also I am finding fib of 2 separately. So it takes a lot of time, right? Whereas in dynamic programming approach, what happens is, only once I will find this fib of 2 value, and only once I will find this fib of 3 value, if suppose, okay. So only once I will find the sub problem solution, only once I will solve it, and I will reutilize it again and again to get the to have the solution for the larger problem instance. So if you have seen clearly, here I am showing you the dynamic programming Fibonacci series. Here the simple idea is memorize. So memo is equal to empty. So here I am taking the memorization table as an empty initial. If n is in the memorization, then simply return the memorization of n. Else if n less than or equal to 2, return f minus 1. Else I am having the same fib of n minus 1 plus fib of n minus 2, the same logic. So finally, I am storing the value in this memory, okay, memorization table, and I am returning the f. So now coming to the recurrence relation here, T of n is equal to T of n minus 1 plus T of n minus 2 plus big O of 1. So why this big O of 1 comes into picture? That is, here whenever I am having either 2 or 1, whenever I am having fib of 2 or fib of 1, simply I am sending the value, that is 1. Only I am returning the value. So big O of 1 for that. So if the term is either 2 or 1 or 0, right? So for the remaining, I am taking this T of n minus 1 plus T of n minus 2. So for computing all these, I require 2 to the power of n by 2. So if I am solving by using by using substitution method, so it will yields me which is greater than or equal to 2 to the power of n by 2. Now coming to this, here the recurrence relation is T of n is equal to T of n minus 1 plus big O of 1. So each time here T of n minus 1, here T of n minus plus T of n minus 2. So here I am not finding once again, here I am just taking that, I am just taking the value from the memorization table. So here no need of computing again this T of n minus 2, that is why it is T of n minus 1 plus big O of 1. If that is a if that is a smaller problem, directly I am sending the solution, right? That is if n is equal to 2 or 1 or 0, right? So the corresponding time required for Fibonacci sequence generation algorithm, if I am using dynamic programming approach, the T of n is equal to T of n minus 1 plus big O of 1, which is equal to big O of n. So here the Fibonacci sequence which uses DNC approach, whose time complexity is greater than or equal to 2 to the power of n by 2, whereas if it uses dynamic programming approach, whose complexity is big O of n. So somewhat it is reduced. For suppose n is equal to 1, what happened? 2 to the power of 1 by 2, right? So which is root of 2, square root of 2 value is 1.414, and here big O of 1, for suppose it is 1 means it is directly 1, right? So now here comparatively 1.414 and here it is 1. So 1 is lesser than 1.414. So somehow we have reduced the time complexity whenever I am using dynamic programming. Coming to the summary, today we have seen what is meant by dynamic programming and what is the principle we have used, that is principle of optimality, and also we have seen the basic difference between greedy approach, DNC approach and dynamic programming. And this is a small assignment, okay. What is the basic difference, differentiate between all the three programming paradigms what you have learned today. Thank you.